Hey guys, this is IM3 Unit 3 Notes number 4. Go ahead and call it Sohcahtoa right at the top up here. I'll talk more about that in a second. But here's your FL. Write it down. And then press play whenever you're ready, okay? Right, so here, in the last 2 or 3 lessons, you guys have been focusing on different ways to finding missing sides, right? So at the very beginning, you guys learned the Pythagorean Theorem. Right, which is basically if you're given 2 sides, you can find the third. Right, if you're given 2 sides, you can find the third. And then you approach our next one. Well, what if you're not given 2 sides, right? Okay. SRTs, which is special right triangles. Well, what if you're given 1 side and 1 special angle? Okay, you can find the third. So Pythagorean theorem only deals with lengths of sides, but when you start incorporating angles that are special, specifically, 30, 60, or 45, you can use what we call special right triangles, right? Now, the third case is what we call trig ratios, which is what you guys are learning. And usually most people associate trig or trigonometric ratios, trig for short. Most people associate trig ratios with what they might have heard before, something called Sohcahtoa. Okay, it's pretty much an easy way to remember how ratios work. But I'll show you guys that in a second, okay? So basically, it's just like number 2. You're given a side. But what if your angle is not special? So I'll just put not special here. Okay, so what if your angle wasn't 30 or 60 or 45, right? You only have 3 special angles there. What if you had like 42 or 56 or 32 degrees, right? You would approach it with trig ratios. So you guys have to understand not only how to do these 3 different approaches, but when to use which, okay? Pythagorean theorem is only used when you know 2 of the 3 sides. Special right triangles, obviously you have to have a special angle in there, okay? Now, you resort to trig ratios if it's not special. That's basically it. And I'm going to show you guys that in a second. Some things that I need you to do first, okay? You will need a calculator, okay? So some people may have the fancy graphing calculator, and that's cool too. You guys will find it handy when you get into pre-calculus or calculus. Some of you may have this scientific calculator right here. And if you don't have any of those, you could always resort to your phone, okay? Now, what I do want to say is this is what I call new school calculators, and this is what I call old school calculators, okay? One is definitely more efficient than the other, but that doesn't mean that you're at a disadvantage if you have the old school, okay? So first thing I want you guys to do is if you have a scientific calculator, something like this, you're going to be looking for a button, either called mode, but if you have this exact one, you're looking for something that is called DRG. That's called degrees, radians, gradients, okay? And when you press that button, right up here, it's currently at rad, which is radians, the R. You want to keep pressing it until it says DEG, which is degrees, okay? You got to be in the right mode, otherwise your calculations are all going to come out different. So you keep pressing that button until you get degrees or DEG on your calculator, okay? Now, if you're on your phone, specifically this iPhone here, but all of them work the same way. If you turn it sideways to your landscape, what you'll notice is these two pictures are very different in that one has rad and one doesn't, okay? And that's controlled by this button here, okay? When you keep clicking on that, you notice that it changes from radians to degrees, degrees to radians. You want it to degrees, pretty much implying that it's blank right here. So you should have it blank. But if it says rad, you want to click on degrees, okay? You got to be in the right mode. So make sure that you guys are not in radian mode, okay? And then that way our calculations will all come out the same, okay? All right, so some things to note. So there was a simple way of figuring out how to remember your trig ratios. So there's this phrase called Sohcahtoa. Sohcahtoa. You may have seen it before, but don't worry if you've forgotten or if you haven't seen this, all right? This is just a simple phrase to remember how the ratios work, okay? So if you take a look on your calculator, whether it's the actual calculator or on your phone, you'll see three buttons. You'll see sine, cosine, and tangent, okay? Now, I'm saying sine, cosine, and tangent, but there's no way that they can fit those words on that tiny little button, so they abbreviated it to SIN. Don't call it sin, okay? So it's sine, cosine, and tangent. So I'm going to write that down for you guys, okay? That, coincidentally, is the first letter to each of these here, sine, cosine, and tangent. So let me just write this here so you guys have it. So SIN on your calculator is called sine. COS on your calculator is cosine. And TAN on your calculator is tangent. Okay? So say sine, cosine, and tangent. Don't say sin, cos, tan. Okay? All right. So the way we remember it is every section here, notice how it's 3 letters, spaced, 3 letters, spaced, 3 letters, right? So every triangle, I'll draw it here. Every triangle has some reference point. So I'm going to go ahead and just call this angle A, okay? B and C. So suppose I told you that I'm standing right at A, okay? If you're theoretically standing right here, directly across from you, that would be called your opposite side. I'll call it OPP for short, opposite side. We know that no matter what, across from the right angle is called our hypotenuse. I'll call it HYP for hypotenuse. And this third side that's right next to you, a fancy word for next to is adjacent, ADJ. So again, this is opposite. This is hypotenuse. And this is adjacent. But all abbreviated as we go on through the lesson, okay? Remember, adjacent just means next to. So what this Sohcahtoa phrase is, you know, it's good that you guys know what the phrase is, but it's even better if you know how to use it, right? So what this is saying is, if you take the sign at where you're standing, in this case it's A, all right, that is equal to the opposite O over the hypotenuse H. Okay, so O over H, O over H. All right. So here, for C, C stands for cosine. So the cosine of A is equal to A over H, right? A over H. So that's adjacent over hypotenuse. Okay? And here's the last one. T stands for tangent, but we'll just write TAN. Tangent of where you're standing will be equal to O over A. In this case, it's opposite over adjacent. Okay? So Sohcahtoa is an easy way to remember your trig ratios. Ratios is just fancy for fractions, okay? So it helps you figure out what your fractions are going to be. Now, what I do want to change here is this A, which I'll point at. Where you're standing is all relative, okay? So here's what I mean by that. If I change my little man right here, and I drew my little man up here, I want you guys to think about what would change. Okay? Press play when you're ready. So if your little man is up there, directly across from him would be your opposite. Now the hypotenuse is always across from the right angle, so that never changes. So the side next to you is your adjacent. So if you notice, your opposite and your adjacent, it depends on where you're standing, okay? Which brings me to my next point here. So in this case, if I am doing the sine of B where I'm standing, sine of B would be opposite at the bottom over hypotenuse on the across from the right angle, right? So the values are going to be different because opposite is going to mean differently depending on where you're standing. Okay, and I won't write the rest, but here's my point. We generalize this. So what we do is instead of saying A or B, they have this Greek letter called theta, okay? Theta looks like a cursive O. Okay, I'll draw it again so you guys can see. And again, theta is Theta. Theta is your angle in general, okay? So here's what I'm trying to get at. Go back to, all the stuff you learned in Algebra 1 or Integrated 1, right? Every time we put a square root, something has to go inside, right? Some number. So you can't just put square root and leave it blank, okay? Same idea. You can't square something and then not put anything here to square it. You would have to put a number there of some sort. You would have to put some number here to square root it. So when you guys use trig functions like sine, cosine, and tangent, sine has to be followed by something. You can't just leave it blank. You can't just say sine, or you can't just say cosine, or you can't just say tangent. It always has to be the sine, cosine, or tangent of wherever you're standing. I'll just put wherever you're standing. Okay, so keep that in mind. You can't just put sine blank. Okay, it has to be the sine of something, the cosine of something, the tangent of something. Okay, so I'm going to show you guys how we actually use this. Here we go. Here's example 1. All right, so I'll leave the directions a little bit short so that we focus on the problem, okay? Find x to the nearest 10th. Okay, in this case, I'll put the nearest 10th, all right? And here's a picture that I'm about to give you, all right? Okay, I'm going to give you a right triangle, and here's what I'm going to give you. I'm going to tell you that this is 62 degrees, and this is 2.7. And this right up here is x. That's what we're looking for, okay? Now, before we actually do this problem, here's what I need you to consider. Could we easily use the Pythagorean theorem here? Could we use special right triangles here? Okay, so we can't use the Pythagorean theorem because we don't have two given sides. We actually only have one given side here. Okay, so we can't use the Pythagorean theorem. And we can't use special right triangles because the angle is not special. It's 62 degrees. The only angles that are special are 30, 60, or 45. So we resort to trig ratios. So here's what you do. They always provide one angle, which happens to be up here. Where the angle is given is going to be dependent on the problem, okay? So what you do is you draw a little man wherever the angle is given. So since the acute angle 62 degrees is up here, I'm going to go ahead and draw my little man right up here for reference, okay? So if he's standing right there, directly across from him is what side? Press play when you're ready. So directly across from the little man would be opposite, okay? Always across from the right angle is called your hypotenuse. And the side next to you would be called adjacent, okay? So if you notice here, there are three sides, but one of the sides has no information, okay? We know that opposite is 2.7. We know the hypotenuse is x, but adjacent, we're not given any information. So I'm going to go ahead and cross that out there, okay? You can even erase it. So the only two sides we're given here is the hypotenuse and our opposite. So we go back to our Sohcahtoa here. Which one has O and H? Out of So, Ka, and Toa, which one has O and H? The answer here is So for sine. Sine has O and H. The other ones don't. Okay? So here we go. So that tells you that we are going to use the sine function. Now remember, every trig function is followed by wherever you're standing. So what angle are you standing at here? Specifically, the little man is right next to the 62 degrees. So I'm going to write 62 degrees equals, and then this is where you put opposite over hypotenuse, okay? So this is going to be opposite over hypotenuse, all right? And then we're going to come back to this one, okay? I'm going to call this A. There's still more solving to do, but I want to focus on the setup, okay? So we're going to come back to that. So leave some space. Here's part B. So let's say I were to draw my triangle this way. Whoops, one more time. Okay. So here is another right triangle. What do you notice that's a little bit different, right? How is this different from the last problem? Right? So one thing to notice is that your given angle is now at the bottom, right? So usually this first one, it was at the top here, but now it's at the base, right? So sometimes it just depends on where that angle is given. So like always, we draw our little man wherever the angle is given. Directly across from the little man is your opposite side. Always across from the right angle is your hypotenuse. And right next to you is called your adjacent. Okay. But if you notice, we have no information regarding the adjacent side. So I'm going to go ahead and erase that. Okay. So we have O and H out of Sohcahtoa. Which one has O and H? In this case, it would be sine because S has the O and the H. So this tells us that we use sine of 34 degrees wherever we're standing equals the opposite. So the opposite side is going to be x over the hypotenuse, which is 3.6. Notice how the setup lands differently with part A and part B. Notice how here in part A, the x is at the bottom. Over here, the x is at the top. But what remains the same is that we're always doing opposite over hypotenuse. Keep that in mind, right? We'll come back to the calculations in a second, okay? Here we go. Here's part C. I'll do part C here. Let's say we have this triangle now. Okay. You can go ahead and try this one on your own. Go as far as you can. And press play whenever you're ready, okay? All right, first thing you want to do is you notice that the angle is not special. So you're going to use trig ratios. And you put your little man there. Or woman. So we stand here across from that little guy or girl is your opposite side. Okay. Always across from the right angle is your hypotenuse. And right next to is called your adjacent. So which side has no information? It's right here. It's your opposite side. Your opposite side this time has no information. So I'm going to go ahead and erase that. So all we have here is adjacent A and hypotenuse H. So I'll write it again, but you guys probably have it in front of you. Out of SOH, CAH, and TOA, which one has the A and the H? In this case, it's cosine C. So this tells you that you're going to use cosine of wherever you're standing, 42 degrees, equals adjacent over hypotenuse. So adjacent over hypotenuse. Okay, so in this case, we used a different trig ratio, right? Because of the two sides that we were given. Okay, let's try another one. We'll come back to the calculations. We're not quite done there, okay? But I'm seeing if you guys can just focus on the setup, okay? Here we go. Let's say I were to draw something like this. And let's have 13 degrees. X 2.4. Okay, go ahead and try this one here. Go as far as you can, actually, but don't calculate. Okay, so again here, you put your little man or woman wherever the angle is given. In this case, it's up top. So I'm going to put my little person there. And directly across from that little person is called your opposite side. Always across from the right angle is your hypotenuse. And right next to you is called your adjacent. Okay? But I noticed that the hypotenuse has no information, so I'll get rid of that. Okay? So we have opposite O and adjacent A. Okay? Out of Sohcahtoa. And if you say it enough, it'll stick, right? Which one has the O and the A here? In this case, it's going to be tangent, T. So that tells you that you should use the tangent function, tan, of wherever you're standing, 13 degrees, is equal to opposite over adjacent. All right? We're going to do one last one here. Here's part E. Last one. Okay, let's do 53 degrees. Let's do 12 in x. Okay, try this one here. Press play when you're ready. Okay, so the angle is given. You're going to throw in your little person. Directly across from this little person is called your opposite. Okay, directly across from your right angle is your hypotenuse. And right next to the little person is your adjacent side. Okay, we know nothing about the hypotenuse here, so I'll get rid of it. So we have O, opposite, and A, adjacent. So out of SOH, CAH, and TOA, that is definitely TOA, right? Because it has the O and the A. So you're going to set up with tangent of wherever you're standing, 53 degrees, equals the opposite over the adjacent. Okay. Notice how this is a little bit different from part D. We use the same trig function, but depending on where I was standing, the x was either at the numerator or at the denominator. So I want you guys to understand that your setup, your x is not always at the top or always at the bottom. It kind of just depends on where everything lands, okay? So that's how you set it up, okay? The next part is just the calculation. So here we go. I'm going to start off with part B, okay? Now, it tends to be a little bit easier when x, the missing side, is in the numerator, okay? Because isolating it is a lot easier. So here we go. Here's what we do. To get x by itself, we have to move the divided by 3.7. The inverse of divided by 3.7 is just multiplying by 3. Sorry, did I say 3.7? 3.6. We would have to multiply by 3.6. And what I do to one side, I do to the other. Okay. That cancels out. So I'm going to write it out up here because I'm running out of space. So x equals 3.6 times the sine of 34 degrees. Okay? Okay, and again, we'll hold off on the calculation, all right? So go ahead and do this one here for part C. Press play when you're ready. So to isolate x, we would have to multiply by 14 here. And the other side, that'll cancel it out. X will come out to 14 times the cosine of 42 degrees. And we'll leave some space there because we have to calculate in a second, okay? Okay. Go ahead and do one more time for part D. Press play when you're ready. So here, to get x by itself, you would have to multiply by 2.4 to cancel this out. But I have to do it to the other side to keep it balanced. So x here will equal 2.4 times the tangent of 13 degrees. Okay? Now, if we take a look at part A and part E, part A and part E, what do they have in common? If you notice, the variable, the missing length, is in the denominator. So the way you solve it is a little bit different. I'll show you mathematically how it works, and then I'll show you a shortcut, okay? So here, you can't solve for x when it's in the denominator. So what you actually have to do, and this is the mathematical approach, so you can just watch, okay? You can write it down if you'd like. What I have to do is I have to bring that back up. So what I'm going to do is I'm going to multiply by x, multiply by x. So what that does is you've just brought your x back up. Okay, so here I have x times the sine of 62 degrees equals 2.7. But the whole idea is to get x by itself. So what we're going to do is we have to get rid of that sine of 62 degrees somehow. So because it's multiplying by the sine of 62, the inverse is to divide by sine of 62 degrees. What I do to one side, I do to the other. So x is equal to 2.7 divided by the sine of 62 degrees. Okay, so here's what I'm going to do with you guys. I am actually going to erase all of these steps in the middle, and I want to see if you guys can come up with a pattern here, okay? So everything in, I don't know, is that maroon? Everything in maroon there is what we started with, and everything in blue here is what we ended up with. Can you guys come up with a shortcut? So if you noticed, sine of 62 in x appears to have just switched places. Okay, so the shortcut here is whenever your x is in the denominator, you can easily switch with your trig ratio. So x will equal 2.7 over the sine of 62. Now, it is a shortcut, but remember that you saw the logic behind it, and it's always important to know the logic behind it instead of just knowing the shortcut, okay? So I want you to go ahead and do part E now. How would you solve for x there? And press play when you're ready. So here, since x is in the denominator, we know that these two pretty much switch mathematically. So x will equal 12 divided by the tangent of 53 degrees. Okay? So solving it is not that bad. Either it's on top where it's easy, and if it's at the bottom, you got to do a little bit of switch. Okay? Now here's the last part for you guys, the calculations, all right? It takes some getting used to, especially if you're not used to a calculator, right? Okay. So I am going to do it both ways, okay? With the new school calculator, it tends to be a little bit easier on the eyes. With the old school calculator, you kind of have to go backwards, and I'll show you both ways. It's not necessarily more difficult. It's just, most people would prefer the new school calculator because what you see on your paper is what you type on your calculator. Whereas the, excuse me, whereas the old school calculator, you kind of have to go backwards, and I'll show you guys how to do that. Okay? All right, so let's start with part B. Okay? So to type this out, okay, now only write the rule that applies to you, okay? So remember, old school is kind of like your iPhone, okay? An easy way to tell if you have a new school or old school calculator is if you press the sign button. If your screen says sign, if SIN pops up when you press sign, then you know you have a new school calculator. If you press sign and you see nothing, that means you have the old school calculator, okay? Okay, so I'll start with new school. New school is easy. You type out exactly what you see. So you would write 3.6 times sine 34. There's no need to write the degree symbol, okay? And then you press equals, okay? Now, that's new school calculator, okay? Old school, I'll put it down here. You have to go a little bit backwards. You would have to type 34, then you would have to press sine, then you would have to multiply 3.6. So I'm going to give you guys a second to do that. Press play whenever you're ready. I'm actually going to do that on the old school calculator right now. So here we go. We have 34. Then I press sine. Then I put times 3.6. You should get, whether it's old school or new school, you should get 2.013094, yada, yada, yada. Okay? But if we're rounding to the nearest tenth, that would just be 2.0 because the digit after is not 5 or larger, so it stays the same. Okay? So I'll box that. All right. So let's try it again. Part C, okay? Whether you have an old school calculator or a new school, go ahead and try this one out. Press play when you're ready. Okay, here, 14 times the cosine of 42 degrees. Go ahead and calculate that. We're going to get, I'm getting 10.40402. So that's approximately just 10.4. Okay, if you didn't get that, let me know. It could be just the way that you're typing it. Okay, that's something that I can easily help you on. Okay. Here's one more. Go ahead and type that one out. Press play when you're ready. Okay, now it's important that you guys are always clearing your calculator by pressing that C or the all clear button, because they might use what you had before if you didn't. Okay, so in this case, 2.4 times the tangent of 13, I'm getting 0.55408 and so on. So that rounds to x equals 0.6. This bumps up to 6 because the digit after is 5 or larger, okay? There you have it. Now, part A and E, okay? New school first, all right? For the new school calculator, you would just type 2.7 divided by sine 62. Okay, so it's kind of like what you see, all right? Now, with the old school calculator, let me do this real quick before I shoot myself in the foot. 2.7 I'm still here, okay? The video's not buffering. I am doing it both on the the new school and the old school. So I just want to double check just to make sure. Okay, let's try this here. Let's do 2. Okay, cool. All right, so if you're using the old school calculator or the iPhone, right? It's funny how the iPhone has an old school calculator. Okay, so with the old school, this is how you would type it. You would type 2.7 divided by, okay, 62 sine, then equals, and you should get 3.05793-ish. Okay? Which rounds to approximately 3.1. Okay. So, some things to help you troubleshoot. 90% of the time, why students have the right setup but the wrong answer is because they're in the wrong mode. So remember at the beginning how I told you guys to be in degree mode. If you're in radian mode, you're going to get different answers, okay? So that's probably 90% of the time students make mistakes, okay? The other 10% of the time is really just knowing the order of it. So whenever you get to a trig function or trig ratio for old school calculators, notice how it's backwards. That's really all you have to pay attention to, okay? And again, you know, one is not easier than the other. It's just different, right? You know, with technological advancements, we were able to make things a little bit more efficient, but that doesn't mean you guys can't use the old school calculator. It still gets the job done, okay? All right, so go ahead and do part E real quick. Try to type that out. and then press play when you're ready to see if your answer's aligned with mine, okay? Okay, so if you did this correctly, and I'm using an old school calculator, I typed 12 divide 53 tan, then equals. Then I got 9.0426, yada, yada, yada. To the nearest tenth, that would be 9.0, approximately. Okay? Let me double check here. I'll do it on a scientific calculator, a new school one. 12 divided by a tangent of 53 degrees. Yep, I'm getting the same answer there, okay? So if you're not getting it, just reach out to me and I'll be happy to go over it with you, all right? Okay, so remember, Sohcahtoa is a good phrase to remember, but it's important that you guys know what Sohcahtoa means. Sohcahtoa lets you remember all of the ratios. It lets you remember all of the ratios. Sohcahtoa, okay? So that's it. Practice on Delta Math. Let me know where I can help you guys.